Hello everyone. Today we're going to be learning about graphing rational functions. Okay, first we're going to learn about horizontal asymptotes. And we're going to use those two in order to graph rational functions. So first, here we're going to look, we have three different criteria. So if the highest degree of the numerator is greater than the highest degree of the denominator, then there is no horizontal asymptotes. Okay, the next one is if the highest degree of the denominator is greater than the highest degree of the numerator, then the horizontal asymptote is at y equals 0. Lastly, if the highest degree of the numerator is the same as the highest degree of the denominator, we use the coefficients as a ratio or as a fraction, and that's where we're going to place our horizontal asymptote. All right, so let's get started. Okay, so this is what we're going to be doing. We're going to follow these, I guess you can call them steps. I like to do it in this order just so I know what my function will look like when I graph it. So the first thing we would do is simplify the function. Okay, next we're going to find horizontal asymptotes, if any, if it has them. Find the vertical asymptotes, if there are any. Okay, and these three we're going to do for this lesson. Okay, and we're going to do the next parts tomorrow. Okay, so let's get started. We're going to have three examples. Remember, we're only completing 1, 2, and 3, and then we're going to continue the notes on the next days, okay? So let's start with example 1. Here we have this function. All right, first step is to simplify this function. But this function is already as simplified as it can get. All right, so here I could just be like, check, done. All right, next we're going to find the horizontal asymptotes, if any. Okay, so for this one, we have to look at over here where we have our criteria. So we're going to look at the highest degree of the numerator. Here, this is the highest degree. This is to the first power. This is also to the first power. So these two are the highest degrees. Okay, and we're going to compare them. Is one of these greater than the other? This is degree 1, this is degree 1. Well, no, there's not one greater than the other. So we're actually looking at this criteria here. So they are the same. So in order to find where the horizontal asymptote here is, we just write the coefficients as a ratio. So my coefficient here is a 1, my coefficient here is a 2. So let me put number 1. Actually, this is number 2. My horizontal asymptote here is y is equal to 1 over 2 or 0.5. But this is our horizontal asymptote. Okay, now let's go to the next one. So we did the second one, check. Now let's go to the next part. So 3, we need to find the vertical asymptotes. All right, and to find the vertical asymptotes, we actually have to set our denominator equal to 0. Okay, so let's look. This is our original function, correct? We have x minus 3, 2x plus 7. This is our function. And we set our denominator equal to 0 to find any vertical asymptotes. Because we cannot have a 0. We cannot divide anything by 0. Okay, so we cannot have a 0 in the denominator. So that's why we end up having an asymptote. All right, so if we set it equal to 0, we just solve for x. All right, so here we have a vertical asymptote at negative 7 over 2. So here I'm going to write is, my vertical asymptote is x equals negative 7 over 2. Or negative 2, I'm sorry, it's 3. Negative 3.5. Okay? Okay, that's where our vertical asymptote is going to be. All right, and that's all we're going to do for these, okay? So if I were, I'm going to go down here. I'm going to draw a little graph. Okay, so I'm going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And the reason I left some spaces because we have to complete parts 4 through 7. Okay, so a horizontal asymptote would be, I'm going to do this as a highlighter color. All right, let me do it in blue. Okay, we're doing y is at 1/2. So 1/2 would be, this is 1, 1/2 would be here. So I would have a horizontal asymptote at y equals 1/2. And then my vertical asymptote would be at negative 3.5. So 1, 2, 3.5 would be right here. So I would draw vertical asymptote here. All right, so far so good. I have my asymptotes. That's all I wanted to do here so far. Just get our asymptotes done. All right, let's do the same thing for now this function. So this function, I have to simplify the function, and this one I can simplify it. So I'm going to simplify it this way. I could factor out a 5 here. X minus 3. And then I can play the x game here to factor. Okay, so what two factors multiply to 15 and add to negative 8? Negative 3 and negative 5. When you multiply them, I get a positive 15. When you add them, I get a negative 8. Write it in factored form. And I simplify, that means I could cancel these guys out. I cancel them out, but it's still an important part of this function. Okay, it's going to help us with something called discontinuity. Okay, and that's going to be number 4. Okay, so far I simplified this to x minus 5. Okay, 5 over x minus 5. So simplify the function. Yes, done. Okay, 2. Now I'm going to find the horizontal asymptote. So I'm going to look at the degrees. This is a degree 1. And up here, there is no variable. So technically, I have x to the degree 0. Okay. So now I look. Is the highest degree of the numerator greater than the highest degree of the denominator? No. Is the highest degree in the denominator greater than the highest degree of the numerator? Yep. This one's bigger. The 1 is bigger than the 0. There's nothing up here. So I would say it's this one. And they are not the same. It's not this one. All right, so that means our horizontal asymptote is at y equals 0. At y equals 0. Okay, number 2 done. Now let's go to 3. We're going to look for any vertical asymptotes. Okay, and for vertical asymptotes, we set our denominator. That's when our denominator equals 0. Because we cannot divide anything by a 0. Okay, that is why we have a horizontal. So it approaches this point, but it never actually reaches it, because we can never divide anything by a 0. So what is our denominator? Our denominator is x minus 5. So we're going to set x minus 5 is equal to 0, and we're going to solve for x. All right, so that means we have this is our horizontal asymptote, and our vertical asymptote is at x equals 5. All right, so 1, 2, 3 done. So now I'm going to do my graph. put it down here on the bottom because I'm leaving space. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so where do we have our horizontal asymptote? At y equals 0. It's horizontal, so y equals 0 is here. That's our horizontal asymptote. All right, and where is our vertical asymptote? Our vertical is at x equals 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So right here, vertical. So far, so good. Vertical asymptote, horizontal asymptote, done. All right, and we're going to go to the last one, last example. All right, here we go. Remember, we're going to continue this again tomorrow, doing 4, 5, 6, and 7. Okay, so now first step is to simplify. All right, let's simplify this guy. This is a difference of squares, so I can write it as x plus 5, x minus 5. Okay, denominator I can factor out of 4. So I divide it out. All right, cool. Anything we can cancel out? Right there. So I can rewrite this as, now remember, even though we canceled these guys out, they're not gone. They're still very important. However, we're just simplifying in order to figure out where is what and how our graph is kind of going to look like. All right, so let's look for our horizontal asymptotes. Horizontal asymptotes, remember we're looking at the degree. This is a degree 1. We don't have any x factors down at the bottom, or even if you look here, there's a 2 here and a 1 here. Okay, so this would be like a degree 0. So let's look at the first one. First criteria, if the highest degree of the numerator is greater than the degree of the denominator, yeah. Is the highest degree in the denominator? No. Are they the same? No. You could check it here or you can check it here. It doesn't matter. Okay, so we have that the highest degree is in the numerator. Yes, a 2 is bigger than a 1. A 1 is bigger than a 0. Okay, so because our degree in the numerator is higher, then we know that there is no horizontal asymptote, because it tells me right here. So no horizontal All right, and let's go to part 3. Vertical asymptotes. So the denominator equals 0. Because we can't divide by a 0, so we would get an asymptote there. All right, so here I have x minus 5. I'm using the simplified form, okay? Can I set 4 equal to 0? Is 4 equal to 0? Can I set this equal to 0? No, I cannot. So therefore, no vertical asymptote. So it has no vertical asymptote and it has no horizontal asymptote. So when I graph, or when I begin to graph, we don't need that much space for this one. If I begin to graph this one, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. I will not have to do any vertical asymptotes, okay? So far we did 1 through 3 for each of these. We found our vertical and horizontal asymptotes. We will continue the rest for each example. We're only doing 3 examples tomorrow, Friday. Okay, talk to you then. Bye.